Hey,
Hey,
Brad,
yes,
how are you doing?
do this. Good. I'm 100%. I'm ready to do this.
Okay, me too. My name is John Horgan. I'm a science writer, and I also teach at Stevens Institute of Technology. I'm in a part of the school uh, that encompasses the humanities and social sciences, arts, and music. And I'm recording a series of videos with some of my colleagues just to let the world and students who are considering going to Stevens or who are headed here this fall to let them know who we are and what we do, what kinds of things we're interested in. So with me today is one of my favorite people at Stevens, Professor Brad Fidler, uh, who is an historian who specializes in computers, the history of computers. So first, Brad, can you tell us why history, and then why history of computing?
So I think the computing came first, actually. I was always interested in computing when I was younger. I ended up going into the social sciences and the humanities just because I think the questions I was most interested in were being pursued in things like uh, political science, history, that kind of thing. But there's a lot of work out there looking at, and a lot of questions looking at and dealing with the ways that computer systems interface with society, for lack of a better term, right? And this is a two-way relationship. It's not only the way that computer systems like impact our lives or impact the economy or politics or something like that, but it's also the way that different organizations, institutions, and other social forces will change the way that we design and build and deploy computer systems, which is one of the things I'm particularly interested in. So it's one way to think about it is it's a look at kind of computing in the world. And so it's not computer science, obviously. Um, and I don't do computer science work proper, but I spend more of my time dealing with like policy and the way that computer systems are developed and administered in specific contexts. So those are like the questions that keep me here. And then there's also a lot of really interesting work because you can think about how we are applying digital computation to more and more problems in the world, right? Computers are showing up everywhere. And whenever you do that, there's typically a question of like, well, how is this going to fit into a pre-existing organization or an aspect of culture or something like that? So whenever you add a computer to something, there's all this kind of interesting stuff about how it's interacting with its environment, and there's work there at this intersection of computation and society, and then also, just as I mentioned, a lot of really interesting questions.
Do you think that a majority of the students at Stevens are planning on entering technology fields in which computers are going to be certainly tools, if not what they're working on directly. So, in your classes, what kinds of things are they going to learn that might help them in their careers?
One of the ways to think about it is in terms of trend lines, right? So you can ask yourself how well you understand a phenomena if you um, can, go back this far or go back this far on a visualization of it. So we look at things such as the evolution of computer and network architecture over time, right? So basic questions like, why are our computers designed the way they are right now? And why are, for example, our computer networks and our distributed systems structured in the way that they are? Often when you're taking a computer science or an engineering course, you're presented with the design principles that we use today as basically the discovery of the objectively true or best way to do something, right? Where in actual fact, if you go back and look at the evolution of these systems, it's typically the case that there was a lot of different options, and we ended up picking one of them, not you almost never because of some kind of like rational and scientific consideration of all the options, right? So the the way that we actually decide on particular designs and like deployment strategies and use cases for computing technologies aren't derived from computer science or software engineering itself, if that makes sense, right? That's where you get into a messy but also fascinating world of um, organizations, institutions, politics, economics, right? Historical context, for lack of a better term. And I think that, you know, in computer science degrees or other related degrees, there is no time to take courses on that kind of stuff, like as part of the core curriculum, right? That there isn't at Stevens, there isn't anywhere else. And I hope that the kind of computing orientated students in my classes can get a better sense of these kind of trend lines of how the use, design, deployment, and whatnot of computing technologies have evolved over time. And that's, I think there's some students just find that interesting, right? Some don't, and I get that, and I have no problem with that. I think I went back and checked my high school write-up like a year ago, and I'd mentioned specifically not liking history classes, like in my write-up, right? So, and I spent all my time in the computer lab, right? So like, I've been there. I know where you're at, these students. I hope that even if it's not what they want to be spending their time with, as like, you know, coursework, if it's not their favorite thing, it's obviously not the path to a high-paying development job, taking courses on history or political theory or something like that. But I do hope that I can give them a kind of utility in terms of understanding trends and processes in their field and in the way that the things they'll be using actually interface in real-world contexts. Because, you know, what determines the like success or failure of a system or, you know, an application or something like that is obviously design matters and your ability as a coder matters, but and your skills as an architect. But historically, if you just kind of look at if you just add it up, trends over the last 50 years and this includes like the last 5 or 10, what succeeds is often due to other factors, and these are social factors.
So you've had some research grants that involved working with some big technology companies like Google. I think one of the defense contractors, is it McDonnell Douglas?
No, I'm actually currently doing work with Google right now. I'm also in the early stages of a project with Lockheed Martin. I'll mention these because they're examples of work that you can do at the intersection of, you might think of it as like policy analysis of like institutional structures, history, and then computing, right? Yeah, so there's work for Google, there's work for Lockheed Martin. I'm doing something for ICANN, which is the Internet Corporation for Assigned Names and Numbers. They're the people that run the domain name system, or the root rather, as well as maintain a bunch of other important systems for the internet. I was a visiting scholar at the University of Southern California's Information Sciences Institute, which is a really prominent contractor and kind of piece of the University of Southern California that deals with computing and in particular networking technologies. And then what else? I feel like I'm missing a couple.
Well, I mean, this goes back to my earlier question about what you can tell students. I would think it adds to your credibility with students that you have a lot of real world experience with industry. You are far from being an ivory tower intellectual looking at computing from afar.
Well, so I mean, this is one of the things I never want to do is pretend that I'm a computer scientist, right? Or like, because when it gets to the actual nitty gritty of architecting a system or something like that's not my thing. I don't try to have that be my thing, and it's really wonderful to teach STEM students, because if you ever need to know, if you're in a lecture and you get into Q&A or a discussion and I wonder like how that's actually implemented, maybe I won't know, but somebody will, right? So it's really great having classes because not only are they, Stephen students really good, but in STEM, they're really good systems thinkers. Like they're really good at thinking about um, uh, technological systems as like an architecture, right? And it's pretty easy just to take those skills that they have and aim them at like social structures. Um, and you can get a lot out of that. And I think um, one of the things that I'd add to kind of like this question of usefulness is that they're going to, let's take computer science for example, right? They'll start somewhere as a programmer, coder, developer, depending on whatever title they end up with, and they won't do that forever. You don't want to be in the trenches programming, ideally. And there's exceptions to this. There's a lot of exceptions to this, but by the time you're my age or your age, ideally you're doing project management, you're telling other people what to do, because there will be kids coming in at like 18, 19, 20, 21, 22, whose memories work better, who are sharper, and who grew up, who got exposed to computers even younger than you somehow, and are just live and breathe this stuff and are so good, right? And it'll be hard to compete. And ideally in one of these fields, you want to be moving up and making decisions that concern the intersection of like product or whatever it is you're working on with the institution you're in or with the market out there, right? And to be able to do that, again, those skills are not a part of a computer science curriculum, and I certainly don't teach all of them, but I do my best to try to get people thinking along those lines so that when they show up to a job, they aren't kind of completely caught off guard with that other stuff, and then have to devote time to thinking about it when they really just want to be working on these cool questions. So I think that's another aspect of how this might be useful. And as an example of how it can be useful, I'm not a computer scientist, and there's work at large firms, and there's also research work. So I'm working on a National Science Foundation grant right now, and then before that, I did other federal government work as well.
All right, let me put you on the spot a little bit here.
Yeah, hot seat.
So
the Horgan hot seat. Let's do it.
Yeah. So we both work at a technology school. Obviously, these days, a lot of questions are being raised about some of the negative influence of technology in our lives, the way that computers and big data systems can be used to keep track of us, to invade our privacy, to manipulate us, these sorts of things. To what extent are you, as an historian specializes in technology, concerned about some of these issues? And to what extent do you bring those concerns into your classroom?
So I'm concerned, right? There's problems with the computer. But I think that the way that these problems manifest themselves are not often inherent in the design. So there's one of these, and I teach courses that are kind of organized around these themes. When we talk about the social problems caused by technology or exacerbated by technology, or and computing in particular, one of the questions that we come back to is how context independent can the impact of a technology be, right? So if you design a certain kind of technology, like some kind of computer, and you see it used in one community over here, and then like one community on the other side of the world, in a totally different like political and economic context, will that tool have the same impact on that society, right? So for example, if you introduce iPhones to the United States and Nepal, does it have the same impact on the society you're in? Probably not. Almost never, right? Because it's interfacing with pre-existing like techniques and cultural things and whatnot. But at the same time, we also suspect that there are some aspects to the design of a technology that will have some kind of similar kind of patterning of the societies in which they um, uh, in which to which they're introduced. So, for example, if you go back to punch card machines, right? The Hollerith punch card tabulators, they were adopted by the Soviet Union and the United States and fascist states as well, and they're all used for very different things. And but one thing that they all had in common, I just realized this is getting really dark.
Okay.
They were used for very different projects, but all of those projects were about developing a individual level resolution view of the population, right? Knowing who everyone was through computational, like organized computational techniques, which we would consider primitive, but were much more efficient than what had come before. So when we're talking about social problems, there's a tendency to either blame the technology altogether and become like a primitivist and say, well, if we just didn't have the internet, maybe these things would be better. And well, they wouldn't. Or to go the other route and say, well, it's completely neutral and it's just the way you use it. And the actual answer to this is actually a fair bit more complex and something that's still being studied. And it's the relationship between like the architecture and design of a particular kind of technology than how it will play out in different contexts, which is the way I think you should think. Like that's the first stage that you have to be able to consider when you're talking about this, if you want to have something reasonable to say. I think the other thing that comes up here is this question of ethics, right? Because one of the things that students, I guess this will be watched by some prospective students, perhaps. Hello. One of the things that they've maybe already been exposed to or will be exposed to is this question about ethics in engineering and computer science. And there's a concern that there's unethical behavior by technologists in the world. And one of the ways that people have kind of turned to the humanities is to teach kids ethics, right? And if you go to anywhere except Stevens, I'm telling you, kids, adults, I'll get to the adult part in a second. If you go anywhere except Stevens, they sit you into these classes where you're just kind of lectured, like, here's what this thinker said about ethics. Here are these like ethical principles. And there's this weird thing we do where we assume that these grown-ups, right? These are like 18-year-olds who, I mean, they've got more, personal development to do, but they're formed humans, right? The idea that they can sit in a class with me for a semester and come out as like a different ethical being, like I have that kind of power or influence over them, right? That's insane, right? So instead, and they already have a moral compass, right? And there's this weird thing we do where we assume that like professors are necessarily more moral or ethical than our students. Maybe we're not, right? Maybe half of the students in my class are actually like really thoughtful and ethical people, right? Maybe I could learn something from them. So I think that these questions about the interface between and the kind of back and forth interactions between computing and society. So not only does how computing impact society, but how do different social forces impact the way we design these systems? We make them better or worse for different things. If students can think clearer about those questions, they're in a better place to apply their own ethical criteria and their own morality to situations they'll be in, because they'll better be able to kind of extrapolate, well, if I do this, what will the consequence be? And then will that be good or bad, like on a moral basis? Or if I do that, what will the consequence be? Their ability to act morally in a consequentialist frame. So their ability to act morally in terms of what will happen, not intent, will be determined to a great extent by how well they understand the relationship between the technologies they're dealing with and society, right? You can intend to be moral, but make horrible decisions and have a terrible consequence, right? So, and it can have a really bad consequence. So what I hope is that by getting people to think a bit clearer and ask somewhat better questions about this relationship and these relationships between technology and society, they can kind of like supercharge their own morality, right? They'll be able to do a better job of figuring out what will be like the right thing to do. And they already know what the right thing to do. They already have the right sentiment about what right and wrong is. That's not what I'm going to teach them. So that's another kind of like thing that I think they get from my classes and other classes in the College of Arts and Letters, where we obviously want people to think ethically, but it's really through like examples and analysis of how things have gone before. It's people aren't going to sit up and be like, here's what Aristotle said about ethics, you have to do that. That's
Right.
not very effective. And just to talk forever without end, one of the cool things about Cal, like where we both teach,
mhm.
is
Cal
that
stands for the College of Arts and Letters. That encompasses the humanities, social sciences, and music and art. Sorry, go ahead.
no, one of the neat things about doing your humanities courses at Stevens is that everybody in our humanities program is engaged directly in some way with technology. We in the science and technology studies program in particular. So you'll be taking your required humanities breadth courses in such a way that very often you get to take humanities courses that are still about your field, are still related to the thing you came to Stevens to do, but you're kind of adding social scientific or humanistic inquiry to these questions you have, rather than just taking like random humanities courses about whatever.
Right. Yeah. I mean, we're trying to create a version of the humanities that's appropriate not only for a school like Stevens, a technology school, but for an era that is so dominated by science and technology.